Hi there everyone. Hope you're all good. Today in O-Level Physics, Lesson 3, Mass, Weight and Density. Mass measures the quantity of matter and inertia of an object. Its SI unit is kilogram. Weight is the gravitational force on that mass, W equals mg, measured in newtons. Mass is constant when an object moves from Earth to the Moon, but weight changes because gravitational field strength G changes. For a 6.0 kilograms object on Earth where G equals 10 N over kilograms, W equals 60 N. A balance compares masses, whereas a force meter or calibrated spring balance measures force and therefore weight. Gravitational field strength is force per unit mass and has unit N over kilograms. It is numerically equal to freefall acceleration in m over s squared. In an exam, use the value of G supplied. See how the arrow for velocity can change length or direction. Acceleration is that rate of change, so you can accelerate even while slowing down, or while turning at constant speed. Never report mass in newtons or weight in kilograms, even though everyday language often blurs the distinction. Density describes how much mass occupies a unit volume. Density equals mass, all over volume. Its SI unit is kilograms m cubed, though G over cm cubed may be convenient. A metal block of mass 540 G and volume 200 cm cubed has density 2.70 G over cm cubed, equivalent to 2,700 kilograms m cubed. Density is a property of a uniform material, not simply a synonym for heaviness. For a regular solid, measure dimensions and calculate volume, then divide measured mass by volume. For an irregular solid that sinks, use water displacement in a measuring cylinder or displacement can. The volume rise equals object volume, provided no air bubbles are trapped and the object is fully submerged. Read the bottom of a water meniscus at eye level and dry the object before measuring mass. Floating depends on forces and average density. An object floats at rest when upthrust equals its weight, so resultant force is zero. A steel ship can float because its hollow shape makes its overall mass divided by enclosed volume less than the density of water. Saying that floating objects have no weight is wrong. Weight remains and is balanced by upthrust. Density can identify a material only when measurements are reliable and the sample is pure. On a mass-volume graph for one material, gradient equals mass, all over volume equals density if mass is vertical. A straight line through the origin indicates constant density. A steeper line means larger density. Check axis orientation before interpreting gradient, and convert units consistently before comparing with reference data. State the measured mass and volume method, convert units consistently, then use density equals mass, all over volume. For graph data, calculate a large triangle gradient and derive its unit from the axes. A stone raises water level from 45 cm cubed to 73 cm cubed and has mass 70 G. Volume equals 28 cm cubed, so density equals 70 all over 28 equals 2.5 G over cm cubed. Do not use initial water volume as object volume, confuse mass with weight, claim that a floating body has no forces, or convert G over cm cubed to kilograms m cubed incorrectly. Practice. Find the weight of a 7.5 kilograms mass where G equals 10 N over kilograms. Answer: W equals 7.5 x 10 equals 75 N. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. A block has mass 0.48 kilograms and dimensions 0.10 m by 0.08 m by 0.05 m. Find its density. Answer: volume equals 0.0004 m cubed, density equals 0.48, all over 0.0004 equals 1,200 kilograms m cubed. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. That's all for mass, weight and density for now. See you next time for continue the course. Stay curious and see you in the next lesson.